Okay, let's go back to our advertisement example. Remember that the P is 0.15, that's our null hypothesis. And the company is hoping its proportion of click-throughs has increased and is testing the hypothesis with an alpha of 0.05. We want to describe the significance level in context. So we want to just say, what does this 0.05 mean in this context? So I'm going to go back up to what is alpha, and I'm just going to apply it here. So alpha is the probability of making a mistake. So I would say it is the probability that the company makes a mistake and what? It rejects the null when in fact it was true. So here it would be the idea of rejecting the 15% of click-throughs. So if you reject that idea, then it means they're going with the idea that it increased. So maybe I would say they make a mistake and conclude that the percent of click-throughs has increased when really it hasn't, is 5%. That's what the 0.05 is, 5%. So it's a 5% probability that the company's going to make a mistake based off what they've seen, and they're going to conclude that the click-throughs has increased when really it didn't. Like when maybe it was just a fluke on that particular day that they were running this test. Okay, next we have a test statistic. What is that? Well, it's a number, and it compares the real world with the null hypothesis world. It's going to compare what we observed with what the null hypothesis says we should see. And there are all kinds of test statistics out there, but the one we're going to look at here in Chapter 8 is specifically called the one proportion z-test statistic. So it's going to tell us how far away that actual sample value was from the expected value. A positive value will mean it was larger than we expected, and a negative will mean it was smaller. So z-values can come back positive and negative. So remember, the null hypothesis is what you expect. And if you see something unexpected, you would be surprised, and you should doubt the null hypothesis. And if you're really surprised, then we should reject the null hypothesis idea altogether. And we have a way to measure our surprise. And this is what everything is going to rely on. The p-value is what is going to drive your conclusion. The p-value measures your surprise by reporting the probability that if the null hypothesis is true, that a test statistic will have a value as extreme or more extreme than what you observed. Okay, so here's the catch. Small p-values close to 0 mean you are surprised and they discredit the null. Large p-values close to 1 mean little or no surprise. So again, these are probabilities. Probabilities can only be between 0 and 1. So small, meaning close to 0, is surprising, discredits the null, and large, closer to 1, is no surprise. So let's look at another example here. Suppose the test you're performing is to see if someone can tell the difference between Coke and Pepsi. You use 20 trials, half with each soda, and the null hypothesis is that they are guessing. So I could write something like H naught is guessing. The person is guessing. About how many should you expect the person to get right under this null hypothesis? So if there are 20 cups just sitting out in front of them and they take a sip of each cup and they guess what one, they really have no idea, they just randomly pick one, then I would probably suppose they should get about half of them right. It's kind of a 50-50 shot there, so I wouldn't be surprised at all if they got close to 50% of them correct. So what if you have two people do this and one of them gets 13 right and the other gets 18 right? Which would have the smaller p-value and why? So look back up to what the p-values tell us. A small p-value, that's what we're interested in here, means you have received a surprise and it discredits the null. So which one of these would be more surprising and would discredit the idea that the person is just guessing? To me, it would be this one. For that exact reason. For the why, I'm going to say exactly what I just said. That's more surprising and discredits the idea the person is guessing. If someone gets 18 out of 20 right, I don't think they're just guessing anymore. I think that maybe they really can tell the difference. Okay, so now let's write out another interpretation here. It says, okay, your alternate hypothesis is, in this case, one-sided, which would be that the probability of them getting it right is more than 50%. So if the probability of them getting it right is more than half, I would say at that point, the alternative is that they can tell the difference and that they're going to get more than half of them right. If the person gets 13 out of 20 of them right, and the p-value comes out to be 0.09, we want to explain the meaning of this p-value. So again, basically what I'm going to do is I'm going to look at this definition of a p-value here, and I'm going to insert the context. So I would say that it is a 9% probability, because that's what the p-value means, it's a probability. So there's a 9% probability that a person is just guessing, because again, this is if the null hypothesis is true. So if it's true, that means the person's guessing, and they get 13 or more, because it says as extreme or more extreme than. So as extreme or more extreme than what we saw. So then they would get 13 or more correct out of 20. Okay, so let's read that back one more time after we've kind of written it here. There's a 9% probability that a person is just guessing and they get 13 or more correct out of 20.